Okay, these are the iteration exercises, and this assumes that you have read the chapter on iteration in Python for Everybody. So let's get started. So the first thing is an example of a while loop, and let's look at what this thing does. The first statement, I is set to 0. Then there is a while statement, while I is less than 5. 0 is less than 5, so because that's true, you enter the scope of the loop, and you do all of these things. You add 1 to I, and you print I. Then you go back to the top of the loop. At this point, I is 1, so I will still be less than 5. So think through what this program does. What will be the last value that gets printed out? So pause the video at this point, stop and think about it, and try it in CoCalc, okay? Okay, I assume that you have done this thing and you know what it does, and you understand why. Let's look at it. And if you realize this, the last thing printed out was 5. At some point I was 4, and then I was incremented to 5, and you printed this thing, printed when I is 5, and then you came back to the top of the loop, and the condition here is I less than 5. So you don't do this again, you go down to whatever followed this set of statements in your program. Okay, this code is one of a number of variations on a theme. And what are the other possibilities? The loop variable I could be initialized at either the first value we want or one before that value. The less than could have been less than or equal. The change in the loop, misspelling, variable could have been the last statement in the loop instead of the first. 3 choices, each with 2 possibilities. How many variations are there? 2 cubed, 8. So what I want you to do now is copy the code above to a Jupyter notebook and try the variations. After you write one, try to predict what the code will do, then run it. Stop the video and take at least 5 minutes playing with this. Remember that you want to look at each of the variations and try to predict for yourself, walk through it, say what will it do, then run it and see what it actually did. Okay, stop the video now and come back in 5 minutes after you've done your job. Okay, I assume that you have now done your thing and you're ready to proceed. And here's an example with all of the opposite choices made. Instead of setting I equal to 0, I set I equal to 1. Instead of testing for less than, I tested for less than or equal to. And instead of making the increment the first thing within the loop, I made it the last thing within the loop. And doggone, after making all those changes, I came up with exactly the same thing. So the point is, there are many ways to do this. And they all look very much the same. And only if you're very carefully thinking about what they're doing will you get them right. So I prefer not to use them. Okay? If you can, do a definite loop, not an indefinite loop. Here's a definite loop for I in range of 5. Okay, so this is the range thing is something that we're introducing here. And what does it do? It produces 0, 1, 2, 3, and 4. So what does this do? The first time through the loop, I is 0. So j is I squared, which will be 0. Okay. Then it'll print both I and j. So the first time through the loop, 0 is not equal to 3. So it won't do whatever this does. So hopefully you've read the chapter on iterations and you know what the break statement will do. Try to predict it. Okay, have you made your prediction? You think you know what it's going to do? Let's take a look. When I was equal to 3, the command was break. So what happened is that you got 1, 0, 0, 1, 1, and 2, 4, but I never got to 3, nor did it get to 4. So what happens when you hit break is that you completely leave the scope of this loop. You go out. You're done with this loop when you hit break. Continue. Look carefully at the explanation of continue in the textbook and try to predict what this is going to do. Stop the video and think, read, whatever you have to do. What will this do? Realize that it looks exactly like the thing before, but it is different in that the statement when I is equal to 3 is continue, not break. Okay? I hope you've stopped the video and you've thought for a few minutes and you know what this is going to do. So let's look. What happened is that when I was 3, this did not get done. When I was 3, instead of doing what followed, you went back to the top of the loop. Okay, so you got the 416. That's the difference between break and continue. Here's an exercise. Prompt a user to provide an integer. If the user gives an inappropriate response, give the user another chance. There is no limit to the possible number of chances. So essentially you're going to start out with an infinite loop. Okay, stop the video. This one's going to take you a few minutes to figure out, I don't know, maybe 10 minutes, maybe 15 minutes. Maybe you're going to have to do some research. But stop the video and do it. Make sure that it works. Of course, you'll have to be working in CoCalc. Okay, like I said, stop the video. And here's the way it works. Here's the input statement. And it says, give me an integer. And if the person has responded correctly, if he's actually entered an integer, then this statement will work. If this statement works, you will break. If this statement does not work, then there will be a failure in the try block, and you'll enter the except block, which says print, try again for an integer, and you'll go back to the top of the loop. The only way you get out of this loop is for this to be successful, and at that point you leave the loop completely, and you'll come down to here, print success, your integer is, and then you print out the value of whatever you entered. Make sure that you do this in CoCalc. If you've been struggling with this, try it, walk through it, okay? And I think maybe Severance should have arranged this thing so that lists and maybe even range were presented before we got into the chapter on iteration. What is a list? Multiple Python objects separated by commas enclosed in square brackets. The in operator can be used to test for the presence of a particular value in the list. The members of the list can be referenced by indexing with square brackets, where the first value has an index of 0, and you can iterate over the objects in the list using the in operator. Here's an example. This list consists of the string Tom, the string Dick, and the number 3. Point, the things in a list do not have to be the same type. And then I ask to print the thing in the list at index 0, which of course is Tom. And what gets printed out is Tom. This is how we iterate over the things in a list. For I in li, print I, and that just goes through each item in the list. It's a definite loop and prints it. Tom, Dick, and 3. So this is the first example, and you can really look at Severance's material and see exactly how this is done. This is one of the standard patterns of programming. I call it the accumulator. And it says create a function average of the list. NL, numeric list. The parameter NL is a list in which all the members are numbers. The function is fruitful and it returns the average value of the numbers in the list. And I want you to test your function using TL is 1, 2, 3, 4. Okay, this is going to take you a few minutes, do a little bit of reading, a little bit of coding, and make sure that it works. And right now, I need you to stop the video and go to CoCalc, and let's get this done. Okay? Okay, so you're back. I assume that you have done your thing, you've done your duty in CoCalc, and you've got a function that works. Let's take a look at my example. Here's the function. Sum is, I start off by setting sum and n both to 0. Then for each item in the list, every time I read an item in the list, I add 1, I add the value of I to sum, and I add 1 to n, the number of things that I found in the list. After I have done this with every item in the list, I calculate the average. It's the sum divided by n. Then I return the average, so it's a fruitful function. Okay, then I create the list TL, and I print average the list of TL, and I get 2.5, which I can see easily is correct. Okay? So stop the video now if you want to look at this and make sure that you understand what it does. And if your attempt at it doesn't work, put this thing in CoCalc and make it work. Okay? So here's another exercise. Create a function average the odds of numeric list by modifying the previous function so that, there's a missing word here, it returns the average value of the odd integers in the list. Again, test it using TL equal 1, 2, 3, 4. And of course what it should do is take the average of the 1 and the 3, which would be 2, right? Okay, so again, as usual, stop the video, do your work, then come back and I'll show you the solution. Okay, you're back. I assume you've done your thing. Here's the solution. The way it's different is that within the loop, it looks exactly like the previous example, but within the loop, you don't unconditionally do these two things. You only do these two things if the remainder upon dividing I by 2 is not 0. That is, this is what tells you that I is an odd integer. Okay, looks exactly like the previous program, but it only does the odd integers. Next exercise, create a function largest of numeric list. Parameter NL is a list of numbers, and the function returns the largest value in the list. Assume that you can't assume anything about the numbers in the list. They may be possible. Test your function with TL equal 1, minus 5, 16, 76, 127, and 4. Okay, you can look at it and you can scan it easily and see that the largest number should be 127. Stop the video, write your program, and come on back. Okay, you're back. I assume that you have done your thing. You've got an example. Let's look. I started off by initializing largest at the first element in the list, which is NL of 0. An alternative is to set largest equal to none, but I like to do it this way. So then you look at every element in the list, and if the element in the list is greater than the current value of large V, then you set large V equal to that thing in the list. The first time through, it's clear when because you've set NL equal to 0, NL of bracket 0 to be the largest value. The first time through, this will be false, but as you read through the rest of the list, you'll find some things that are in fact larger. And then you return whatever LRGV was at the end, and you print that largest, and you get 127, which is correct. Okay, look at this thing. If you want to stop the video and pause and look at it, feel free. But let's go on to the next solution, the next exercise. Modify largest to create smallest. Okay, so stop the video and do your thing, then come back and I'll show you my solution. The difference between largest and smallest is that right here the test is if I is less than SMLV, then you set SMLV equal to I. So that's the end of these exercises. I hope this helped you nail down what iteration does.